So we're going to have a look at this particular question, mostly because there's a good graphing side to it, and something that's worth having a look at. Firstly, we're going to look at the question and variables that pop up in it. Purchase for $150,000, scrap value of $9,000 in 5 years. Find the annual depreciation under straight line and then reducing balance. So we've got our piece of machinery, and we want to work out the annual depreciation under for a straight line method. Basically, we look at, we start with the $150,000. Sorry, just had a little glitch. So we're continuing on. We want to find the annual depreciation. So we know that all in all, the total depreciation, the cumulative depreciation, is $150,000 minus the $9,000. Over here in my CAS. That's $141,000. And straight line is, of course, constant, so it's the same amount each year. So to work out the straight line depreciation is going to be the $141,000 divided by 5 years. And I'm going to lose the same amount each year. And what I get there is $28,200. That's how much I lose each year under straight line method. Part B says to work it out using the reducing balance method. To sort out the annual depreciation amount using a reducing balance is a little bit more complicated. I'm going to set up a little depreciation schedule here. This is the first amount, so I'm starting with. I'm going to write in here the depreciation for the year and then what I'm left with. And then, of course, this is what I'm left with is what I start with the next year. I know that after 5 years I'm left with $9,000. So first I need to work out the rate. I need to know the interest rate that it's depreciating at. Now, the purchase price is $150,000. Rate I don't know, and tick that box. How many time period is 5 years? And the book value after 5 years, I'm told, is $9,000. So now I can solve for R here. And it tells me that R is 43.03%. So that means each year I use 43%, lose 43%. So I'm going to go back to my main screen. I'll just clear this out. I'm starting with 150,000 and I lose 43.03%. So that means the amount that I lose is 64,545, which is going to leave me with $85,455. So then that's what I start with at the beginning of this year, $85,455. And now I'm going to times that by my 0.433. And that means this year I lose $36,771.29. So now I'm going to do 85,455. Because I can just drag that out, so save typing it. Minus this one. So that means that then this year I'm left with $48,683.71. That's what I start with the next year. Now I'm going to times that by what I lose in the year. That means I lose 20,948.60. I'm going to take this one, subtract this one. I'm now left with 27,735. That's what I start with the next year. Now I lose use 11,000. 934.41. Leaves me with 15,869. Hopefully that gets me pretty close to the 9,000 I need. There could be a little bit of rounding error due to my sense as I'm going through, and the original interest rate, as we rounded that to begin with. So now I'm going to lose 6,799 and 4 cents. This is the final. There we are, 9,001, so it's pretty close to 9,000. So in here are my annual depreciation values. This is the simple interest one, the equivalent, sorry, the straight line. I lost 28,200 each year, and here I lose 64,000 in the first year, and that decreases, losing only 6,500 in the fifth year. This question is really good because now it asks me to graph them. Now, to consider what we might do to graph these two things together, what we're going to do is we're going to look at how we can turn each of these depreciation rules into rules that use y's and x's so that we can plot them on our Cartesian plane here. So the straight line one, this is the rule, and when these are the values we've got, we know that the purchase price was 150,000. Interest rate is 18.8, and we can work that out by we lose 28,200 each year, so my interest rate is 18.8% times t over 100. Now what I can do with that is I can rewrite that. Instead of using y's and x's, I mean book values and times, we could pretend like this is my y-axis, 150,000, 1 minus 18.8, instead of time, I use that as my x-axis. This is my, I'm going to call this equation 1. I want to plot this in there because we need to actually plot both of these on the one graph. Now my reducing balance rule is this one here. It's the exponential one. Again, I've got the purchase price is 150,000. My interest rate we worked out in the previous question is 0.4303, and I'm going to use the same axis value here so I can type it onto my CAS. So that's going to turn this one into y equals 150,000, 1 minus 4303 to the x. And we're going to type both equation 1 and equation 2 into our CAS. So let's go here. You can do this in two places, in the main screen or in the graph screen. I'm going to do it here in the main screen. Just clear everything out. So we just start by typing this in. Y equals 150,000 times, I'm going to use my fraction template, 1 minus 18.8x over 100. And now I need to do my other one. Here's y equals 150,000, 1 minus 0.4303 to the power of x. Now I press this button here, the graph button. The graph appears down the bottom. I click on that first answer there, drag it down, and on the second answer, drag it down. You need to think and ask yourself, why can't I see the graphs yet? Well, on our y-axis, we've only gone between minus 3 and 3. Our y-axis is our book value. We know that that needs to start at least 150,000, so this is not big enough. This box here, with the 4 arrows, that'll adjust the screen. We know that we want y from 0. Let's go to 160,000, and we can see the top of the graph. X is the time, and we know that we're only going from 0 up to 5 years. So I'll just go one more so I can see it. Press OK. Here's our graph. I can use my hands here so I can turn it and move it around. So here is my 150,000. Here is my reducing balance depreciation. I lose a lot more at the beginning and then less at the end. And my straight line is the constant, same amount each year. So there's the value as it goes. This is the graph of book value. It's telling you what it's worth at any time, which I could look up across the bottom one. And that's how I would graph these two equations on the one set of axes.